In this video, we'll be coding for collision of line particle, but before doing that, we're going to do some changing. We're going to actually, for a collision of two particles to occur, we're going to create new logic. I just got an idea to do it differently. Okay, we'll see how we'll do that, and also there's no changing in this code. It's the same code as previous. If you run it, same one in which they were actually bouncing back from the boundary. I have just put them in different particles, put in different rows. This code just to see it easily. There's no change as of it in this code. As far as state code, there is little change. I actually created a different logic to actually go for bouncing back of the boundaries. I just created the maximum of position vector for particular particle should not be greater than 20. That's what it's saying. Maximum of the position vector of particle should not be greater than b2 comma 1. That's just should not be greater than 20, and minimum of it should not be less than this. If it is, then it will occur that the boundary collision will occur, and you already know what will happen after it will occur. The thing I want to do in this starting of this video is that I want to create different logic, a different reasoning for the collision of two particles. But would that be, I'm gonna assume, not assume, there will be two particles. As they will be moving, or if one is moving close to another, the distance between the two particles will decrease. So I'm going to create a minimum value of this distance, maybe 0. I can go for 0 or 0.5 something, at which if the minimum distance is acquired, collision will occur. So this is like Eulerian distance now. It is like more generalized now, I think. Let's code for that part. Like two particles moving close to each other, distance is less. So how would you do that? You have to go for Eulerian distance. That's called Eulerian distance, Eulerian test. Maybe there's a function, or I should just write the code. Help Eulerian distance. Maybe there is something like that. Is there Eulerian distance? Okay, just call it. It's not that tough. It's square root sqrt. I'm gonna go for xqrt. So there are two particles. Here you subtract x2 minus x1, y2 minus y1, z2 minus y1, and add those three up. So I'm gonna go for x first comma column last one. Why am I gonna go for last one? I'm gonna tell last. This time it's only one size. There is nothing like last column. There's only one column. There's a reason I'm gonna go for last, because in particle line collision I'm gonna include center of mass that I'm gonna create at the end. At that time it would be needed only the collision of the center I will be considering that time. That's what it means. And okay, 3 times third time x. Now go for y. First particle, second particle, first particle, second particle, number of particles at the end. Okay, Eulerian distance lets me is there anything here wrong? Z, yet I have tried Z. What is okay? Square root, square. Okay, I need one more. How many do I need? I'm not closing them. Wait a second. This one, this one, this one. What are these three for? Wait a second. So something is not good. Okay, it's here. I understand now. I'll put one here at the end, one here, and one here. I don't need this much. Let's see now. Okay, good. 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 I'm putting, yep. Okay, let's see the values as in close to each other. Yep, 0, it's getting closer. So I can put like this statement Eulerian distance as Eulerian distance is if Eulerian distance less than equivalent to, let's say the size is 0.5, go for 0.5. Let's see if it works now. I don't need this one to show me this time. I'll run it. Okay, it's working now. Fine. So this reasoning is working very well. Now it can work in 3 dimension as well. So this is more generalized, I guess. Okay, maybe for boundary collision, should I do the same thing for x-axis, for y-axis, and for z-axis? No, this I think this is good. Like if any one of the thing is like greater than the bound, it should. But this time bound is same. That's why it's working. If the boundary is different, then it's not gonna work. Okay, this is good. So it's working. Now we're gonna go for the line particle. Okay, let's suppose for a particle body there are 2 points. Let's keep m as 2. So total mass of these particles is actually equivalent to 5 and now the mass matrix, first of all there is 2 and the third one will be the center of mass, so there are 3, so I have to distribute it into 3. So it should be m should be equivalent to ones of number of n, number of rows is n, and m plus 1. Let's say it should be like this exactly, and mass of everyone should be equivalent to, so it's like 5, so this one divided by 3, 5 divided by 3, and I have just do it row wise. Okay, you can do like this, dot product with total mass divided by 3. Let's see if it's working. 1.667, that's working fine. If I actually go for 10 this one, or let's keep it nice for 6, let's go for 9, 18. Let's see if it's working. 333, 666, it's working very fine. Keep it same. So mass matrix I have made. Here doesn't matter, this doesn't matter, this doesn't matter, bound doesn't matter. Okay, now x matters actually. So at 0, I'm gonna keep it first particle x number of pointers would be 3. So one I'm gonna keep at 0, another one I'm gonna keep at 1, and okay, I need only 2, and the second particle x would be at 10 and 11. Same thing, y would be same on the same axis. I have to keep them at, and I have include another x. If you have had seen one of my lectures, I include another center of mass by using this center of mass function, the simple nothing else. Simple, including the mean at the end of the matrix. Here I have to go for x and x, run it, and you will see the result 0, 0, 1, 1. So at 0.5 and 10, it will be center of mass. Okay, do the same thing for this. Y, same thing for z. Okay, let's see, this one is okay. Let's see position vector. How is position vector looking? Double click here. So position vector is like this: x 3 3, particle 1 x-axis these 3, y-axis, and it should be 9. Why is it not? Is less 3 4 5 6 7 8 9. Something is missing. 0 0. Wait a second. What is z? Z doesn't have an additional. Now it's okay. Okay, I just didn't run it up. I think now it's okay. Still not running. Easy not. Okay, I haven't added up another point to it. That's good. So 3 3 3 for everything. The only thing I need is 3 6 and this one. That's how I'm gonna code it, I think. Let's see. Okay, u, if I'm gonna create u for same, it will be like 5 5 5. Particle 1, everyone will be 5 5 5 theta. This one 0 0 0 0 0 0. Same thing for this. Same thing for this. Same thing for this acceleration as well. Let's initialize the first step. Dimension where we can concatenate it are not consistent. Where is there? Where is there? Let me see. Okay, here. Okay, let's see. It's working fine. Now this is particle 1 with 3 point masses, particle 2 with 3 points. I have to make this collide with this one and come back. Okay, this much is working very good. Initialization is good. The most important part is the state. That is the thing. I can change the state of one particle that is the center of mass and collide the center of masses. It's 0.5, so one thing is clear, like I kept it as 0.5 minimum distance. Now I can go for, like, if I'm keeping 0.5 center mass, so it should be 1 actually minimum distance. So I need to do that thing. This thing should not be chosen start, it should be problem specified. So I need to create this minimum point that would be 10 from okay, that's where is it, x, okay, here. So 0.5. Let me see mean of x. All 150. Mean difference. It should be 1. That I have to add those things up. So from center to the end point, it would be same. So I have to subtract last minus the first. Okay, let me see PV. This minus this in here. This minus this is 0. Here is this. Yes, this side is 0 0. You can go for like 0.5, and I have to that thing. Okay, I can do like this. Okay, the distance x is equal to x and minus x and minus 1. What is x and minus 1? 0.5. What is x and? It is what? Wait a second. X. This minus this. Okay, it has to be like this. X first row comma and 1 comma and nothing. I think it will work. 0.5. It will be absolute. Absolute now. Okay, the same thing has to be done for second. It is same. Particle 1, particle, then these two has to be added. Okay, x1 and go for x2. They have to be added. Same thing has to be done with this one. So test is equal to test x1 minus dist x2, even absolute of this one also, abs not minus plus. Okay, positional vector, I'm saying an easy one, maybe as an easy one. Okay, let me do the same thing for y and same thing y, y, over here, over here, here, this one is a 0, dist x, dist y, and distance z, key, and I had to go for like dist is equivalent to maximum of dist x comma dist y comma maybe dist z. When two are provided, there are three provided. Okay, let's not do that thing. Two. Okay, for two it does work maximum, but three it doesn't work. So I can do like this one. Control X, Control Y. Dist is equivalent to maximum of dist x comma dist y, and here I can go for dist is equivalent to maximum of dist z comma dist. Oh, it will work. Yep, that's one. First I'm comparing x and y, then that x and y with z. So, and this one I'm gonna give an input in here, and this thing I'm gonna create here a variable, and here it should be here. Okay, now it's working. This is good. Now I have to go for position vector. Okay, let me see how are they looking when running the code. Okay, no problem. Error 0.5, 0.5, there's 0.5. This thing is working well. This thing I'm not gonna care about yet. 10, 10, 10. So there are like 333s. Everybody's going to with 333. So I'm gonna go for one thing. Let me go comma m here, number of points to each particle, comma m. So there are two for j is equal to 1 to m plus 1, because number 2 points, center mass 3 points. So why would I do that thing? Let's see. I don't know yet how to do that thing. Wait. So everybody has 3 points. X is changing 0.5, 0.5, 0.5. What was the initial one? It was not 0.5 actually. If I run only this thing, run x. Wait a second, it's not even showing x 0, 1, 0.5. So this is wrong. What am I? It's working like this is wrong. So I would go for j is equal to 1 to m. DC arrows first. Okay, I need to see one thing first. Control C, Control V. Let run one and show me an error. What happened here? Okay, so answer is 0, 10. All rows. First position vector 1, 2, 3. It should be, it's 3, 2. I think 2 times only. There's two particles, not two particles, n times only. Wait a second. Let me give another input as n is equal to m comma n, m comma n. Okay, two particles are there, so 1, 2 times only. Okay, that is it. So the first one is like change position vector of, okay, another loop for k is equal to 1 to m plus 1, and run one on another end, and control A, control I. Okay, so when 1, 2, 3, so at that time that would be cool. Now let's see. So first I have changed on 1, 2, 3. Let me see one thing. A is equal to 1, 2, 3, 4, 5. A 1, 2, 2, comma. Row cannot be like this. First it could be all comma 1 to 2. Okay, I can do like this one also. So I don't need to do that thing. So I don't need to go for k. Work on one theory. I'm not cutting this video, just see how will I do it. You will get an idea. Okay, so x from all rows. Okay, all rows means first position vector particle and second particle 1, 2, n. N is 1 into m plus 1. Let me see. So it will be like 1 to 1. M plus 1 is how much? 3. 3 ones are 3. 1 to 3. So in second case, it will be like n would be like 2. M will be 3. No, m will be 2. 2 plus 1, 3 into 2, 6. So the thing is, this one should be n. Yep. 1 to. So it's like 1, 2, 3. In the second one, like 2. Okay, second one should not be like 2. Second one should be like second particle. Wait a second. Let me think about this one. So for first, I'm running two particles. I can run both particles at the same time. Yes, I can run it. The only thing that is different is DCV X. I had to go for only X position vector. The first three are X. Wait a second, let me see the output of this one first. Output of this one is like 3 for the same particle. So this is the same particle. It will give me output of this. Okay. Okay. 1, 2, 3. Think about it. DCV1, all rows first. Where is this DCV? This is cos of alpha, beta, and gamma. X find Z. So this is an error. No way this can be X. What am I doing wrong in here? Let me run it here. Yep. Let me run it here. So let me run this one first. It's 1, 1. U. U is 555. And this is 0.1. Okay. So I can run X is like first 3. So all rows from N, I don't need to run even this thing. Wait a second, maybe this is gonna work. So it will be like from 1 to Control A, Control I. So X will be from all rows from 1 to 3. Okay. Okay, I'm going to delete this thing. Let's see if X is working nicely. Okay, it's like 0.5, 1.5, and 1. So it's working nicely. This is the first point. This is the second point. This is the center of mass. Same thing for this. X is working, and then the same thing for Y. It will be like from m plus 2 to twice m plus 1. Yep, it's like 2 plus 2 is 4 to 6. 3 to the 6. And in here it would be from m to m plus 1. In here, right, this thing plus 1 to 3 times m plus 1. So m plus 1 would be 3, 3s are 9. Let's see it works. Let's see those two. Okay, it's working good. X is okay. Y is also okay. Z. So coordinates are working well. Okay, let me see this position vector. Okay, this is also working good. So now what's that? X data must be a vector. Okay, it has to be a vector. Go for like X all. It won't change a thing. It will change, make it a one row matrix. First of all, in this time, X is like those matrix of 2 cross 3, then it will be like 0.5, 10.5. It will put in same row or same column. For just plotting, just for plotting, nothing else. Yep. Up until collision, it's working nicely. After collision, it's going that bad. So the error is in here because, so why would this be an error? Because position vector maybe here something is happening. They are colliding, and the position vector, it must not, it makes not this. So the error is in one thing is there. M was needed and was not needed, so just delete this thing out for starters. Okay, let me see the error now. After collision, I had to put this thing again. Control C, Control V. It was showing error here, not there. Actually, not here. It was showing error here. Let me see. Yep, not there actually. So collision is also working. So they got beside each other because of this here. they should move opposed to each other actually. Now it's okay. Now the boundary collision is not working good. Let me do that thing also. So as far as boundary collision is happening, so this is the thing. Now in here, I need to see everything one by one. This thing, if logic, okay, display work. First of all, this close this thing. This thing is working. Now this UI, let me see how is UI looking. And just close this thing out for starters. Okay. So use like this, it should not be like that. I think it should not be like that. Because I'm talking about ith row, but first row, all columns. It should be 3. But every time it's only 2. What is it? First of all, before that, let me see what is U like. In here, U is like 2 cross 3. In here, it's like 2 cross 1. And somewhere, U is changing. So U, where am I getting U? U is here. Yep, there it is not there. There it is here. Okay, now I know where is there. So you are gonna go for this enter. So there would be like, what would be it like? So U is like ones of, U is going to U is already ones of. Wait a second. Let me see. Stop it initially. So it's already, size is already there. I don't need to care about the size then. Okay. So the first particle, it will be like first row, comma, all, if 2 particles are there, is equal to out. I need to make it generalized. Maybe there's, okay. It would be out into ones of size of, okay, size of rows 1 comma. You can take any size. I would take maybe x, no, not x. I would take size of u, maybe itself. Yep, size of, what have I written, u comma 2. Write this thing again. Second row, it will be out 2, size of ones of, size of ones of number of 1 comma 1 comma 1 row, u comma 2, u comma 2. Let me see if it's working now. Yep. So let's see in here. So here it's working. Go for u here. 5 5 5. After this, both will be having some velocity. So this is also working. Okay. In here now, let me see what's the value. Something is happening here. After logic is hitting, u, this is the first one. Then it's if maxi of p, not all, for I is equal to 1 to size of, wait a second, there thing I need to start from this point. So I is grown from 1 to size of m. What is the size of m? Let me see. M has a size of, here we can see from this point, m is, okay, it's 1 to 3, it's 2, so 2 times is gonna run. So for particle first, so it should be like maxi of particle like PV. Oh my goodness, that is a thing. I throw in all column first row, so position vector, I will open position vector. So this means maximum of P every this thing. Okay, right. This is going beyond 20 minimum. Okay, logic is also working. Okay, here it will be an error. So I throw first row all columns. Yep, I know exactly what's the mistake. I had to put these 3 things there. I haven't changed. Why I'm not changing initially? Where is there anything else? Control I throw and why? Okay, the thing I need to change is in here. I comma, wait a second, I need to see what was the initial one. Control C, Control V, Control Y. Okay, now is the thing. It's X I comma all, I comma all, I comma 1, I comma all, I comma 1. So in here, okay, now this is the thing. I just choose the same thing in here. In here also I this I just go for I and I. And where else I need I? DCV. I. Let's hope this time it works. I just bounce back. Okay, now there's an error. Okay, no problem. There's an error. So the error is in 1 by 3 and 2 by 3. Not all. Okay, dokie. 1, 2. I require some of this thing. Okay, now again, what did I do wrong? So because the size of left is 1 by 3 and 2. Okay, 2 by 3. Where did it went? So where is this 2 coming from? Maybe this thing is. I should have changed it here. Yep, I have changed it here, not here. Let's run it. If error is there, again it will show 1 by 6 and size of right side is 1 by 3. X, Y, and Z. 1 to this, 1 to this, 1 to this. I did. In here, I just did all. Let me see if it works or all. I'm not even thinking what I'm doing. It's writing the same thing. I will think when it won't work. Okay, it's working. There is your answer solution to collision of 1D particle. That was very nice. Haven't cut anything. If there was error, you will see how I proceeded to have I just corrected that thing. I think there's more generalized one. You can add number of particles. Now you can even add a surface to it. No matter, volume. Just I have to go for beyond up for 3D collision.